So Unit 9 was all about categorical data. In the next two units, Units 10 and 11, we're going to be doing correlation and regression, which is a way to look at the relationship between two quantitative variables. So we'll start off looking at the relationship between the price and the age of some used Honda Civics, so starting with a pretty simple example. So you can see here that we have the equation of the line that we're using for prediction. There's different ways to write the equation of a line. You may have seen mx plus b. We're just going to use b0 for the intercept and then b1 for the slope. But don't worry too much about this notation. As long as you remember that the number that goes with x, that's the slope. The one that stands on its own, that's the intercept. And we're using y hat to stand for the predicted value of y. So luckily this is really straightforward to do in JMP. I'll show you how to do it really quickly. So here's the Honda Civic data. We're going to do analyze fit y by x. Remember, that's what we've done in the past when we were looking at the relationship between two variables. So we'll put price as our y, that's our response variable. Age for x, that's our explanatory variable. And it pops up a scatter plot automatically. To do the regression, all we have to do is click the down arrow and choose fit line, and then all the rest of the information that we need comes out automatically, so that's really nice. Okay, so right here in the parameter estimates table, this is giving us the slope and intercept of the line. So we're using these numbers right here. So we have y hat, remember that's our predicted price in this situation. And I'm going to round to 2 decimal places since we're talking about money. So 19,338 and 50 cents, that's the intercept, minus 1,579.47, that's the slope, and then age. So x that we're plugging in there, that's the age of the car, and y hat, that's the predicted price of the car. Okay, so let's interpret these coefficients. The slope is the predicted change in y for a 1 unit increase in x. Okay, so if we wanted to put this in context, we would say that the predicted price decreases, because this is a negative slope, the predicted price decreases by this amount, $1,579.47 per year. Notice I say that it's predicted to decrease. I could also say it decreases on average, right? This isn't a perfect relationship. And then the intercept, that's going to be the predicted value of y when x equals 0. So if you imagine plugging in 0 into this equation, that term would go away and you'd be left with just the intercept. Okay, so this is, in this context, the predicted price of a car where the x equals 0, so where the age of the car is equal to 0. Predicted price of a car where age equals 0 is $19,338.50. We do want to be careful here though. Extrapolation is when we try to make a prediction based on an x value that is outside the range of our data set. And the problem is that these predictions may not be accurate. So at first, it doesn't seem like 0 is very far outside the range of our data set, but if we think about how car prices work, we don't necessarily expect this to be a steady line going back to 0, right? Because we know that cars lose a lot of value as soon as you drive them off the lot, and we don't have any new cars in our data set, right? Our data are for used cars. So the problem with this, the problem with extrapolation, is that the same linear trend that we've been using for these used cars, the same linear trend may not apply to new cars. And I would say that it probably won't. In fact, if I were to guess what would happen here, I would say that the model would probably underestimate the price. Right, because new cars are going to be more expensive and this model is not going to take that into account, so it would probably underestimate the price. Okay, so we've interpreted the coefficients. Let's actually use this to make some predictions. So if we wanted to predict the price for a 5-year-old Honda Civic, all we have to do is just plug into that equation. So y hat is our predicted price, 1938.50 is the intercept, 1,579.47 is the slope, and I'm just plugging in 5 because this is a 5-year-old car, so I'm just plugging in age here. And I get my predicted price is $11,441.15. So that's the predicted price for a 5-year-old Honda Civic. But of course our predictions aren't always exactly right. So we define the residual as the difference between the actual value, so y here is representing the actual value, and y hat is indicating the predicted value. Okay, so positive residuals, that happens when your actual value minus your predicted value is positive. So in other words, that means that the actual values are higher than predicted. So if we look at the graph, anytime we have points that are above the line, these have positive residuals. On the other hand, if y minus y hat is less than 0, that's saying that your actual value is less than your predicted value. So if we look at all of these cars where the actual price was lower than predicted, all of those are going to have negative residuals. And let's calculate the residual for one particular car. We have a 5-year-old Honda Civic that sold for $8,395. Okay, so we've got our residual, we're representing that with E, is the actual minus the predicted. So the actual price of the car, $8,395, minus the predicted price, we calculated this a second ago, $11,441.15, and we end up with a negative residual, negative $3,046.15. Okay, so if we wanted to show that on the plot, we can just draw a vertical line from this actual car up to the predicted value. So we can see that the predicted value on the line is higher than the actual price of the car, and that's why we have a negative residual for this point.